Hello. Now today we will discuss the next instrument type, which is electrodynamics type instrument. Now this electrodynamic type instrument is very similar to PMMC instrument, but the main difference between the PMMC instrument and the electrodynamic type instrument is that in the electrodynamic type instrument the general operation is confined to AC current only. Okay, and as AC current pass through this instrument coil, then the permanent magnet is replaced by magnetic field. So now we will discuss the construction of this instrument. Now you can see this is the construction of the electrodynamic type instrument. In the electrodynamic type, this is the physical construction. In the electrodynamic type instrument, the moving coil is same with the pointer arrangement, which the pointer actually moves through the scale to dictate the unknown current or the voltage given its input, and this is the two field coil. Now these two field coil is actually provided to produce the magnetic field. Now we can see here that the major difference with the PMMC instrument, this magnetic field coil is substituted in place of permanent magnet. Okay, that means in the case of the PMMC instrument there is a permanent magnet. Two permanent magnets are placed, and in between that the spring coil arrangement, that means the moving coil arrangement and the pointer arrangement is fixed. But in the case of the electrodynamic type instrument, here we are replacing the permanent magnet, that's two permanent magnet with magnetic field coil. Okay, magnetic field coil means magnet with the coil. Now within the moving coil is same, it is pivoted between the magnetic field coil, moving coil, stationary field coil. When the current flows through the pivot coil, the two fluxes interact, and the PMMC instrument, as in the case of the PMMC instrument, when the current passing through this field coil, okay, then the flux will interact, produces a force, and this force will cause the pointer to move from its zero position. And there is another difference with the PMMC instrument, is that the first difference I have told that in place of the permanent magnet, here we are replacing the magnetic coil. Okay, so this is the first difference with the PMMC instrument. PMMC instrument has permanent magnet, but the electrodynamic type instrument and moving coil. And this coil arrangement, between this coil arrangement is same from PMMC instrument and moving coil instrument, sorry, electrodynamic type instrument. And the second major difference is that in the case of the PMMC instrument, I have said that to minimize the damping effect, we are employing the eddy current to minimize the damping effect. Okay, but here this principle is not applied. Here we are employing a air vane or the air chamber. This lightweight vane pushes air around the enclosure. That means this arrangement is actually enclosed by air. That means air has been pushed into this arrangement, so that this air causes some amount of friction which prevents the pointer oscillation. So that is the another difference with the PMMC instrument. PMMC instrument provide or minimize the damping or the oscillation of the pointer with the help of the eddy current, but this eddy current effect is not suitable for electrodynamic type instrument, as AC operation is performed in the electrodynamic type instrument. So here we are producing, or we are minimizing the damping effect of the pointer with the help of the air. Air is actually pushes the air, that means air is actually pushes into the pointer arrangement, and this air actually provides some amount of friction which minimize the damping of the pointer. Now the AC operation, and before going into the AC operation, I am going to show you a simplified diagram of the instrument. So this is the simplified diagram of the instrument. So you can see that when current is passing through the coil. This is your moving coil. Okay, sorry, this is your moving coil and this is your magnetic coil. These two are magnetic coil. Okay, current is flows through. Suppose current is passed through in that direction. Now this current is going like that, again pass through the second coil, and then the current direction reverses in the moving coil. That is the main thing in the case of the electrodynamic type instrument. Electrodynamic type instrument, so it is said that when a current pass through this, when AC current is passed through this arrangement, then these two magnetic coil, the current direction of these two magnetic coil is, and the current direction of the moving coil which is pivoted between these two magnetic coil are reversed. That is the main principle of this electrodynamic type instrument. Okay, so as the current of the magnetic coil and the current of the moving coil in opposite direction, AC current, then you can understand this figure. Now in this figure it is said that when current passes through this arrangement, then north pole and south pole is being created as the magnetic, this coil and this coil. These three, there have been three coils here. Okay, when current passes through that, so there is south pole created and here also north pole created, and again it is like that. But as soon as it is created this type of arrangement, this moving coil, as the current direction is opposite, so this moving coil produces, okay, the north and south pole like that. So this is south, this is north for this coil 1, and this is south, this is north, this is for coil 2, and this is moving coil, this is magnetic coil, and this is moving coil. So in the moving coil, this is north pole and this is south pole. So you can see that here I want to say that the whatever may be the current in the, here we are employing the AC current. Now the AC current changes direction for every half of the cycle. Okay, so for the first half of the cycle, but if we change the AC current direction, the pointer always move in the rightward direction. How this happen? That is the main principle of this instrument. So I am again repeating, then this instrument is employing the AC current. So AC current means it is changes its direction for every half cycle. Okay, so for the positive half cycle, whatever may be the arrangement of the north and the south pole, that will cause the pointer in the rightward direction obviously, and for the negative half cycle also, whatever may be the north and the south pole arrangement, that will again cause the pointer to the rightward direction only. That is the unidirectional torque is produced whatever may be the current direction. That is the main thing to discuss here. Okay, so as you can see that this is south, this is north pole, and in the case of the moving coil, this is north and this is south, and in the second coil, this is north, this is south. So moving coil and this coil, this is similar pole and this is similar pole. Okay, this moving coil spring arrangement, this is the controlling force. So this moving coil actually responsible for pointer movement. So this is the same pole and this is the same pole. So there is a repelling force is produces. As the repelling force is produces, the pointer will move in the rightward direction. So that is the main thing to be discussed here. Okay, that means this is north pole and this is north pole. That means same pole is, whatever may be the current direction, same pole is produced like that with the coil and the moving coil and the magnetic coil. Okay, and there, as the same pole is being created, then there is a repelling force generated. This repelling force is actually responsible for moving the pointer to the rightward direction. So you can say in the, when current flow from left to right, and in the opposite direction also, when the current flow from right to left, then also you can see that for the left to right there is a north north south south pole is being created. But if we reverse the current direction, then so that is the main operating principle. That means whatever may be the current direction, as it is employing the AC current, so whatever may be the current direction, that is not responsible for pointer to move in the opposite direction. That means pointer will always move in the right direction, whatever may be the direction of the current in the instrument. So the instrument is so calibrated that whatever may be the direction of the current, the pole, whatever may be the pole created with the moving coil and the magnetic coil, this is your magnetic coil, this is your moving coil, this is your magnetic coil. So the pole arrangement is so that the moving coil and the magnetic coil, the pole arrangement is same. Okay, as the pole arrangement is same, so there must be a repelling force, and this repelling force always causing the pointer to move in the rightward direction. Okay, so I am just showing you the technical writing here. So this is your AC operation. AC operation means electrodynamic instrument connected in series, and the current series means moving coil and the magnetic coil. So current direction is such that flux will set up south pole and the north pole like that. This is south, this is your north. But in the case of the moving coil, S pole and N pole. Okay, the N pole of the moving coil adjacent to the N pole of the left hand side of the coil. That means this coil arrangement is such that it produces the same amount of force or the repelling force, so that the pointer will, whatever may be the current direction, pointer will always move into the right direction. Okay, and it is not a linear scale. That means in the case of the permanent magnet, there is a linear scale, this is the linear scale. But if you go into the torque equation of this type of instrument, that means the deflection is proportional to current square. As this deflection is proportional to the current square, that means the scale of the instrument, okay, calibrated in which follow this type of equation. That means scale is not linear actually. Okay, the scale is non-linear. Okay, in the case of the PMMC instrument, it is almost linear, but in the case of the electrodynamic type instrument, it is non-linear scale due to the torque equation, deflection of the torque equation. You can see that this is the deflection, whatever may be the deflection, instrument deflection, that is proportional to the current passing through, square of the current passing through this. So you cannot calibrate the scale linearly, you have to calibrate the scale non-linear fashion. An instrument is not marked at plus and minus, terminal are not marked as plus and minus, as in the case of the any voltmeter or the ammeter arrangement. Whatever you see any voltmeter, DC voltmeter or ammeter, there is a plus and minus symbol is there where you want to connect the unknown current or voltages. But in the case of the electrodynamic type instrument, there is no marking of there, that actually suggesting that the instrument is not polarized. Instrument is not polarized means it is actually designed to measure the AC current. That is the main principle. Okay, so this is written that the instrument deflection is proportional to the square of the current or the RMS value of the current, rather than not this I is the RMS value of the current. This is the deflecting torque equation. And now I want to discuss some advantages. This is some advantages and disadvantages. The terminal are not polarized and can be calibrated on DC as well as an AC, as there is no difference. Measurement of RMS value of the, regardless of the waveform, that means this current is I square, this is the RMS value of the current. It can be used as ammeter, voltmeter, and the main application of this instrument is wattmeter. Okay, and disadvantages: nonlinear scale calibration is quite difficult, and larger operating current is required, that means it is less sensitive to electronic instrument, and heavier moving coil. Okay, so greater friction error, and limited AC frequency operation, and expensive to the manufacturer. The scale is non-linear, and there is a heavier moving coil is employed. So that is the some advantages and some disadvantages. Thank you.